together, and we can expand out the numerator.
Wait! Is that a talking axolotl?
No way! Is that a talking penguin?
I didn't know axolotls could do math. Help me! I'm on the verge of failing my next math exam.
Yes, in fact, did you know that axolotls are the smartest creatures on Earth? Well, in Sec 3, math becomes E-math, and if you wondered what the E stands for, it stands for everybody has to suffer, no matter if you're a penguin or the reincarnation of Albert Einstein. Now get ready to be educated, so grab your pencils and calculators because we are covering all the topics in Sec 3 E-math. Do you know how in MasterChef they have to plate their food and arrange it to look fancy? Completing the square is just like trying to arrange a normie quadratic equation into its fancy form. The first step is to make sure that the coefficient of x squared is positive. So let's factorize out a negative from this minus x squared and the minus 4x term over here, and we can just leave this plus 5 outside here. Now this will be factorized into x plus something squared minus something squared. This something is just the coefficient of x divided by 2. So let's put 4 over 2 inside here. Now the last step is to just expand out the negative, and we can simplify this to get negative x plus 2 squared plus 9. In order to sketch this graph, we know that it's a sad face just by looking at the coefficient of x squared. The next step is to obtain the turning point. So let's compare it to this general form over here, and you can see that the h value is 2, the k value is 9. Now the magic formula for the turning point is negative h, k. So the turning point is negative 2, 9, and let's plot this on the graph here. Next we want to find out the x-intercepts. So let's equate y is equals to 0, and after shifting some stuff around, we square root both sides to get x plus 2 is equals to plus minus of 3, which gives us x is equals to 1 or x is equals to minus 5, which is kind of how you solve a quadratic using the completing the square method. Now let's put those x-intercepts on our graph, so x is equals to 1 goes here, and x is equals to negative 5 is here. The last step is to find the y-intercept by equating x is equals to 0, and we get the value of y is equals to 5, and we plot it on the graph and we are done. I have no idea why, but this math formula has the most memes created about it that I've seen online. But this type of quadratic word problem always comes out in the O-levels for some weird reason. So to find the time taken for this hot water dispenser, we can kind of draw out the red triangle, and since we want to find the number of minutes, it's actually the number of liters, which is 1200 divided by the rate, which is x. And we can repeat the same thing for the cold water tap, which works out to be 1200 divided by x plus 10. Now, for the next part, since the hot water takes 5 minutes longer, we can take the hot water value minus the cold water value and equals to 5. Now we need to combine these two fractions together, and we can expand out the numerator. And then we can just do cross multiplication and shift everything to one side of the equation. Now we finally factorize out a 5 and we manage to prove the equation over here. For this quadratic equation, if we try to use the normal mode 33 calculator method, we realize that we get some really weird decimals, so we can't really use that. Now, introducing the quadratic formula! The most complicated formula that you have to memorize, where a, b, and c are the coefficients of the quadratic equation. So let's put these values into the equation and first evaluate what's inside the square root here to get your method mark. And finally, we can get the x values of 44.2 or negative 54.2. And we kind of have to reject this value here because the flow rate can't be negative. Finally, we can just use this x value and we can get the final answer of 22.1 minutes. Just like algebra, there's a few indices rules that you have to remember. When dealing with two numbers multiplied together, we kind of add up the power. So this becomes 2 to the power of 3 plus 2, which is 2 to the power of 5. When dividing, we minus the power, so this becomes 2 to the power of 3 minus 2, which is 2 to the power of 1. When something in a bracket is raised to a power, we can actually multiply the powers together. So this here becomes 2 to the power of 3 times 2. When you have a fraction and the power is negative, you can actually flip the fraction to turn the power to be a positive, and then you can expand the power in. Also a quick side note, anything to the power of 0 is equals to just 1. Lastly, when you see a cube root, since this is a 3, it can be written as a power of 1 over 3. For this question, the first step is to combine the power for the 5s, and whenever you see a 1 here, you always think of something to the power of 0 is equals to 1. So let's write this as 5 to the power of 0. So since the base number is the same, we can actually compare the indices. So 2x plus 1 is equals to 0, and we can finally solve for x is equals to negative half. Okay, this one is a little tricky because all of this is a plus instead of a times. So we can't use our indices law straight away. The trick here is to factorize out 2 to the power of x from all of these 2 to the power of x's over here, and we get 2 to the power of x times 4, which we can rewrite the 4 to be 2 to the power of 2. Now we combine the power for the 2's, and we can compare the indices to get x plus 2 is equals to 8, and then the final answer of x is equals to 6. Okay, here's my secret pro tip for this topic. If you forget a certain rule, right, you can use your calculator to double check. So for example, if you don't know whether to add up the power or to multiply them, you just kind of make up some example like 2 to the power of 3 times 2 to the power of 2, and you just press it into your calculator to double check which method is the correct one. For this topic, we always aim to convert very big or small numbers into something called standard form, which consists of a number between 1 to 10 multiplied by 10 to the power of something. So when we say 7.8 billion, it actually becomes 7.8 times 10 to the power of 9. Okay, to convert this really small number here, we try to shift this decimal point so that we get a number from between 1 to 10. So we keep shifting until we get 2.34 over here. We count the number of skips this decimal point had to move, so because it skips 6 times, so it becomes 2.34 times 10 to the power of negative 6. Compound interest is probably one of the most useful formula if you want to end up being richer than Elon Musk. In this formula, P is the principal amount of money we have, R over 100 represents the rate, so for example, for a 3% interest rate, the R value is equals to 3. Finally, the N is the time period, so if it's compounded yearly, N represents the number of years. Okay, so let's try out this question here where the principal amount is $5,000, and since it's compounded yearly and the rate is 8%, so the value of R is equals to 8 and N is equals to 5 years. So putting all of it into our formula, we get $7,346.64, which represents the total amount that we have now. So the interest earned is actually this amount over here minus our principal amount, which is $5,000, and we get our final answer over here. Now part B is actually quite tricky because it's compounded monthly now, but everything in the question is given in years. So the trick is to convert everything to months, so we divide the rate by 12, so it's 8 over 12% per month, and now 5 years becomes 60 months. So let's substitute all these values in and we can get the final amount of $7,449.23. And you notice that it's a bit more than what we get in part A. So we realize that compounding something more frequently actually earns you more money. Now that's super stonks.
While your favorite math axolotl is going to be slacking off playing some Valorant, the penguin's here to teach you. So on this topic, we're going to be talking about points and lines in 2 dimensions. Let's look at the 3 main concepts for this question, which is the gradient formula, the distance formula, and finding the equation of a straight line. So in order to use the gradient formula, let's call this point x1 and y1, and this point x2 and y2. Since the gradient is the change in y over the change in x, all we need to do is to sub in the values, and we get the value of m equals 2. Next is the distance formula, which kind of looks complicated, but if you take a second look, it looks like our best friend Pythagoras' theorem. This distance over here is the hypotenuse. And this distance is x2 minus x1 and y2 minus y1. So putting all of these into the distance formula, we get the distance of AB equals to 8.94 units. I forgot, I gotta stream. Bye! Catch you guys later!
Let's go! I just finished top fragging in my Valo game. A huge shout out goes to my good friend and best penguin gamer, Pengu Nozomi on Twitch. Okay, let's carry on with the last part over here, which is to find the equation of the line in the form of y is equals to mx plus c. We already have the value of m, which is equals to 2, so let's sub in any one of these points that are on the line to solve for our c value over here. So let's sub in x is equals to 2 and y is equals to 9, and we get the value of c is equals to 5, and finally the equation of the line AB is equals to y is equals to 2x plus 5. Okay, let's try out this more difficult question, and they want us to find this point S over here. The trick is to find out the equations of these two lines and substitute one equation into another and solve them simultaneously. Since L2 cuts the y-axis at -4, the equation is y is equals to -4. We first calculate the gradient of L1 by using the gradient formula by putting these 2 points in, and we get the gradient of -2/3. To find c, I'm gonna use a big brain move because this line over here cuts the y-axis at 8 over here. So we instantly know that c is equals to 8. So after doing simultaneous using these two equations, we get the final answer of x is equals to 18 and y is equals to -4. To find the area of this triangle PRS, we gotta use half times base times height. So this here is the base, and since it's a horizontal line, we can take the x value of s, which is 18 minus 1 over here, and we get the length of 17. We do the same method to find the perpendicular height, so 8 minus -4 gives us 12. So finally doing half times base times height, it gives us the area of 102 units squared. Alright, for this part it's actually pretty tricky because we have to draw an imaginary line over here from R to PS, so that this over here is a right angle, and let's call this perpendicular distance D. Since we already have the area of the triangle, we're gonna find a way to use it by doing half times base times height again, but this time PS is the base and this is the height over here. So to find PS, we can actually use the distance formula and we can get PS is equals to the square root of 468. Now we can just do half times square root of 468 times the height and equate it to 102, and we can solve for the length of D to be 9.43 units. You're probably thinking, how in the world am I gonna memorize all these graph shapes over here? Aha! As the big brain axolotl, I'm gonna teach you my top secret method in just a bit. But first, let's sort out all these graph shapes by the powers of x, and for this one, since it's x to the power of 0, it's just 1, so it's just a horizontal line. Next, x to the power of 1 is a straight line, x squared is a quadratic, and x cubed is something called a cubic function, which looks like a sideways S shape over here. There's a really special case where x is actually the exponent, where it actually never touches the x-axis and just keeps going up like this. Also, the intersection point here is 1. Okay, now, when it's x to the power of -1, it kinda looks like cat whiskers in opposite directions, and x to the power of -2 looks like a volcano where the whiskers are like beside each other. Now, introducing my top secret method, which I call the -101 method. So, to sketch this graph, I know that it's a x to the power of -1 case, so it kinda looks something like this. So the trick here is to sub in x is equals to -1, 0, and 1 inside to get our corresponding y values. When you sub in x is equals to 0, it actually gives you a math error, so it gives us a clue that it's an asymptote. Now we just plot these two coordinates over here on the graph and we know which direction to draw our whiskers, and we get our final graph like this. Don't believe me? Let's do one more. Since x cubed looks something like this, we sub in again -101, we plot out all the points, and since it looks like a S shape over here, we sketch the graph like this. This method works for all variants once you identify the general shape of it, and you can always plot more points if you're still unsure on how to draw the graph. It is time for the dreaded long graph question that appears every year in O-level math paper 2. Now, the first part is super easy by now. They give you a bunch of points, we plot them and connect them with a smooth curve like this. I for one and hashtag team freehand because I was way too broke to afford a curve ruler. For part A, when we draw out the equation y is equals to 0 on the graph, we can see that there is only one intersection here, so the answer is that there's only one solution. A tangent is basically a line that touches the graph at exactly one point. So we put our ruler like this and sort of move it closer to the graph until it touches the point 23 over here, and we draw it out. Now, to find the equation of the tangent, we find the 2 points, say here and here, that lie on this line, and we just use the gradient formula to get the gradient of the tangent to be 4. Now we can either sub in one of the coordinates over here, or we can read the y-intercept to get the c value of -5. So the equation of the tangent is y is equals to 4x minus 5. Okay, now the last part seems to be really difficult for many students, but the whole idea is to make this equation here look like our original equation. So since it's x cubed divided by 2, let's divide the whole equation by 2. Okay, now, are you ready to see some magic? Since the original equation has a minus 2x term, but our equation now is minus 3x, we rewrite it as minus 2x minus x. And for the plus 3 here, since our equation doesn't have anything, we can rewrite this as plus 3 minus 3. Now we just underline all the terms that's in our original equation, and then we just shift everything that we don't want to the other side. And ta-da! The straight line graph that we have to draw is over here, which is y is equals to x plus 3. Now, in order to draw this line, we just create 3 points like this and we draw out the line. Because we want to solve for this equation over here, we need to look for the intersection points between the line and the curve. So here, here, and here are the intersection points. And we note down the x coordinates of these points, and we have our 3 final answers of x is equals to negative 2.5, 0, and 2.5. Trust me when I say that this topic is really easy if you study physics, because it's basically like the same thing. For math, taking physics is better than bio. There, I said it, okay? Now imagine if you have a distance, speed, and acceleration ladder like this. The secret is that going down the ladder is finding the gradient, and going up the ladder is finding the area under the graph. So for this question here, it gives us the speed time graph. The gradient is the acceleration, and the area under graph is the distance. For part A, they tell us that the distance for the first 10 seconds is 130 meters. So we have to equate the area under the graph to 130. So let's use the area of trapezium formula, and we can solve for the v value of v is equals to 20 meters per second. If you forget the trapezium formula, it's all good because you can actually split up this area into like a rectangle and a triangle, and you can still get v equals to 20 like this. For the next part, the deceleration of 0.8 means that the gradient of this line is negative 0.8 because it's sloping downwards. So again, we mark out these 2 points and we use the gradient formula, and we solve for the t value to be t is equals to 53 seconds. Now for the last part, the average speed is the total distance over the total time, so let's work out these 3 areas separately and we add them up to get 740 meters. Then we just do 740 divided by 53 to get the average speed of 14 meters per second. Okay, sometimes teachers love to be really evil and set this kind of volume flow rate problem, which they love to mix with the Sec 1 and Sec 2 topics. So if we fill up this cylinder with water and we want to plot the height of the water against time, it's a straight line graph because it has a uniform cross section. Now for these two, it gets a little bit trickier. So for this volcano looking tank, we look at the top and the bottom and we ask ourselves, will the water fill up fast or slow? So the bottom here fills up slowly, so it means it has a shallow gradient, and we can draw it on the graph like this. The top fills up fast, so it has a steep gradient, so we draw it on the graph and we kind of know how the curve looks like over here. So we can do the same for the other one, where it goes from a steep gradient to a shallow gradient, like this. Okay, if you haven't seen this meme from my Sec 2 video, go watch it now, because we're gonna prove that 2 triangles are similar or congruent. For congruency tests, the most obvious one is when all 3 sides are the same, so these 2 are congruent by the SSS congruency test. The next congruency test is when 2 sides and 1 angle are the same, but please take note that this angle here has to be an included angle, which means that it's kinda sandwiched between the 2 sides over here. And we call this the SAS congruency test. The next one is where 2 angles and 1 side are the same, and we call it the AAS congruency test. Now the last one is the most unique one, where it only works in a right-angled triangle where the hypotenuse and 1 other side are the same, and we call it the RHS test. Now let's apply what we learned for this question over here, and we want to prove that these 2 triangles are congruent. So we flip this triangle around and we redraw. Our goal is to find either a common side or a common angle first, so here AC is a common side. Next, taking note of the ordering, 65 degrees is the same over here, and these two angles are the same because of alternate angles. Since we found two angles and one side, we can say that triangle ADC is congruent to triangle CBA. Now for similarity, there are 3 tests, but honestly from my experience, the one that comes out the most commonly is the AA test. It's basically trying to find two pairs of the same angles to prove that the triangles are similar. The other two are more rare, but the SSS test and the SAS test is all about finding the sides of the triangle that have a similar ratio. For this case, it's 5/3 like this. Okay, again, I'm gonna use Minecraft to explain this thing called the square cube law. So let's say if I have a 1x1 carpet here, the area is 1 meter square. Now if I 3 times the length, the area is actually 3 times 3, which is 9 times of the original area. The formula is that the ratio of area 1 to area 2 is L1 over L2 squared. Okay, now let's take a look at a 1x1x1 cube, and the volume is 1 meter cube. Now if we 3 times the length, the volume is 3 times 3 times 3, which is equals to 27 times of the original volume. So the formula of the ratio of volume 1 to volume 2 is L1 over L2 cubed. For this question, we can see that the water level forms a smaller cone that's geometrically similar to the bigger cone. Since it's 8/27 full of water, we know that V1 over V2 is equals to 8/27. Now the ratio of H to 18 is our L1 over L2, so we can use the formula of L1 over L2 cubed is equals to V1 over V2, and we just cube root both sides and we can get the H value to be 12 cm. Now to find the ratio of the curved surface area A1 to A2, we can use the area formula of A1 over A2 is equals to L1 over L2 squared. Since L1 is 12 and L2 is 18, we can get the final area ratio of 4:9. Do you guys remember the game Fruit Ninja? A bisector is basically like cutting something in half. So a perpendicular bisector cuts a line in half like this, where these two are equal and this is 90 degrees. And an angle bisector is cutting an angle in half, where this new angle equals to this new angle over here. To construct a perpendicular bisector, we're gonna need a compass for this. So let's set it to some reasonable length and we don't adjust it anymore. Now we put the pointy end on A and we draw an arc like this, and then we put the pointy end on B and we draw an arc like this so that it cuts the first arc. Now we just do the same for the bottom part here and we connect the intersection of the two arcs together like this, and ta-da! We have our perpendicular bisector. Okay, now for the angle bisector, we put our pointy end on A and we draw an arc that cuts this line over here and then this line over here. Now we're going to shift our pointy end to this intersection point of the line and the arc, and then we draw another arc, then we shift our pointy end to the other point and we draw another arc like this. We can lastly connect point A to this arc intersection, and there we go, we have our angle bisector. The most difficult kind of question is when they ask you to find some point D which is equidistant to points A, B, and C. So the trick is to actually draw a perpendicular bisector of AB like this, and then draw another perpendicular bisector of BC like this. Now the point D is just the intersection of these two perpendicular bisectors, and then we are done. Let's say a question asks you to find the sine and the cosine value of this obtuse angle B over here, which may seem impossible, but that's where you gotta get creative. Since A is 180 minus B, the trick is to find the value of sine A and cosine A first. So using Pythagoras theorem and the same Tuakaso method, sine A is equals to 5/13 and cosine A is equals to 12/13. Okay, now here's the really important formula relating A and B together. So sine A is equals to sine B, but cosine A is equals to negative cosine B. So the value of sine B is just the same, which is 5/13. Now for cosine B, we have to put a negative sign, so the answer is negative 12/13, and then we are done. Let me show you another formula to calculate the area of the triangle, where area is equals to half AB sine C. The important thing is that this C over here must be an included angle, where you can see that C is kind of sandwiched between the lengths A and B over here. Let's try out this question where they actually give you the area and ask you to find the value of theta over here. So using the formula half AB sine theta is equals to 19, we can do some manipulation, and taking the sine inverse gives us the value of theta to be 71.8 degrees. Okay, now 71 degrees for theta seems a little bit sus, given that they say that the theta value is obtuse. So remember our little trick where sine A is equals to sine B, and B is 180 degrees minus A, so the value of theta can also be 180 minus theta, which gives us 108.2 as our final answer. Have you ever played those matching card games as a kid where you gotta like flip open the cards and memorize to find the same pairs? The sine rule formula is kinda like playing those card games where you try to have to find a pair, while the cosine rule you can think of it as like 3 people chilling in a corner looking out into the horizon. Now for a triangle that has the lengths of A, B, and C, if we take the length A over here and go all the way across, we can call this angle big A. So this A and big A is counted as one pair in our sine rule formula like this. The cosine rule is used when we have two sides and the included angle in the corner like this, and we want to find the side that's opposite of the angle over here. Don't worry if the formula looks super complicated, because thank God it's given in the formula sheet. The question can either ask you to find the length A, which you can get by doing a square root on both sides, or the question can also ask you to find the angle by doing some algebra and eventually doing a cosine inverse to get the angle over here. So the million-dollar question is always, do we use the sine rule or the cosine rule? Okay, let's look at AC over here. Since we want to find this over here, we realize that we have a pair of 23 degrees and 6 over here, so we know we gotta use the sine rule. Our 40 degrees and AC is the other pair, so let's do AC over sine 40 is equals to 6 over sine 23, and then we can just solve for AC to get 9.87 cm. For part B, the ratio of the area of this triangle to this triangle over here is 3:5, and we can see that they share a common perpendicular height. So let's convert these areas to half times base times height. So the base for this triangle is 6, and the base for this triangle is CD. Now we can just cancel off the half and the h to get the value of CD to be 10 cm. We can actually find the angle of ACD by doing 180 minus these two angles over here, and we can just do 180 minus it again to get 63 degrees. Or if you're a 200 IQ axolotl like me, you can use the exterior angles of triangle property. Now since there's two lengths and this angle is chilling in the corner like this, we can use the cosine rule to find the opposite side AD over here. So B and C are the lengths over here, and the angle C is 63 degrees, and we can get the final value of AD to be 10.4 cm. Bearings kind of remind me of those pirate ship maps. So for this question, when they say that the bearing of A from K, the first step is to draw a north on the second letter, which is K. Now we're gonna go clockwise from the north until we hit the line AK. So this angle here over here is the bearing, which is 131 degrees. Also, there's this really weird thing about bearings that it's always 3 digits. So this angle is 54 degrees, which gives us the angle of BKA to be 77 degrees. Now, to find the length of AB, as you can see we have the length of these two sides and 77 degrees chilling in the corner. That means it's time to use the cosine rule, and we can get the length of AB to be 36.2 kilometers. Okay, for long questions like this, we kind of want to use the 5SF value before rounding off, because this value will be more accurate when you use in future calculations. So to find the bearing of A from B, we draw the north at B and we go clockwise until we hit the line AB. And let's call this angle here theta, and the bearing is just 180 plus theta. Now we gotta realize that this north line over here is parallel to this north line, so by alternate angles property, this big angle here is also 54 degrees. So we can just take 54 degrees minus the angle KBA to find the value of theta. Now we form two pairs of angles like this, and using the sine rule, and this time we have to take the sine inverse of the angle of KBA to be 40.3. Then we can get the value of theta to be 54 minus 40.3, which gives us 13.7 degrees. And this angle, which is the bearing of A from B, is 180 plus 13.7, which is equals to 193.7 degrees. For the last part, the shortest distance from A to BK is basically like trying to find the perpendicular height of a triangle. Okay, now, when you see a right angle triangle, there's probably a good chance you gotta use Trois Casseaux. So redrawing out the triangle like this, we can easily solve for L to be 23.4 kilometers. Alternatively, you can find the area of the triangle using half AB sine C and equating it to half times base times height, which is L. It's a little bit more complicated, but you both get the same answer. So imagine you're standing on top of a building and you look into the horizon, so that's your horizontal. You look up and see a plane. So this angle between the horizontal and the plane is called the angle of elevation. Now you also realize that you're too broke to go on holiday, so you feel the wave of depression. So you look down, and this here is the angle of depression. For this question over here, the angle of elevation is like if you're standing at P and you look up to the lighthouse at T, which forms this angle over here. So let's redraw this right angle triangle. In order to find PR, again these three are in one corner, so we can use the cosine rule to find the opposite side, and PR is equals to 33.3. Now because this length is 33.3, we can find the value of theta using trois quarts. So tangent theta is opposite over adjacent, and we can get the value of theta to be equals to 18.3 degrees. A segment is when you cut a circle across like this, and a sector is when you cut the circle like a pizza slice over here. And the goal for this topic is to calculate things like the sector arc length, which is the crust of the pizza, and the sector area, which is the area of this pizza slice over here. Do you remember when you switched browsing the internet from light mode to dark mode for the first time? Radians and degrees are kinda just like light mode and dark mode, where they can always be converted from one form to another. So all you have to remember is that 180 degrees is equals to pi radian. So 1 degree is equals to pi over 180 radians. Then if you want to find something like 60 degrees, you just multiply both sides by 60 and here you go. Now the magic formula to convert from degrees to radians, we multiply by pi over 180, and the opposite, to convert from radians to degrees, we divide by pi over 180. Even though these two formulas are given in the formula sheet, you must remember that this angle theta here must be in radians, and you have to change your calculator into radian mode. So in the pizza slice over here, both of these sides are r, and the angle in between them is theta. So the arc length is r theta, and the area of the pizza is half r squared theta. Okay, let's try out this question where you gotta find this obtuse angle here in radians. Since both of these are the radius, which is 6, and the area of AOB is 9, we can do half AB sine C is equals to 9, and we solve for the angle AOB. Okay, now, here comes the tricky part. Even in radian mode, when you do a sine inverse, you gotta consider that the acute angle is 0.523 radians, and also the obtuse angle by doing pi minus 0.523. Okay, now, for a pro tip, you can actually rewrite this 0.523 as a nice fraction as pi over something. We take this exact value and divide it by pi, which gives us 1 over 6, and we know that the acute angle is pi over 6, and the obtuse angle is 5 pi over 6. And since the question says here that the angle is obtuse, we reject the pi over 6 value. For the next part, we can find this area of the pizza slice, which is the minor sector, by using half r squared theta, and the theta value here is 5 pi over 6, which we calculated just now, and then we can just minus off the area of the triangle, which is 9, and that gives us the shaded area of 38.1 units squared. The last part asks us to calculate the crust of the big pizza slice, which is the major arc length right here. And the trick is to find the reflex angle of this and just do r theta. Since 360 degrees is 2 pi, this reflex angle is just 2 pi minus 5 pi over 6, which gives us 7 pi over 6. Now we can just do r theta and we can get the arc length of 22 units. Okay, there's this other really cool property of sectors, which is that if you fold this sector together inwards and join these two ends together, it will actually form a cone. Like, isn't that so cool? So, the arc length from the sector over here will form the circumference of the base of the cone over here. And also, the radius of the sector will be the cone's slant height over here. And also, the area of the sector is equal to the curved surface area of the cone. For this question, since they want us to find the volume of the cone, they gave us the radius and the angle here, and we're going to find the arc length BC, and we're going to equate it to the circumference of the cone, which is 2 pi r, and then we can solve for the radius of the cone. Now, since the slant height is 10 cm, we can draw out our right-angled triangle, and we can solve for the vertical height h of the cone. Now, the last step is to put in all our values inside the volume formula, and we can get the volume of the cone to be 50.7 cm cubed. Welcome to the most annoying topic in the whole of eMath because there's like a billion new theorems about circles that you have to memorize. But fret not because your favorite axolotls got you. Okay, let's start with this chord in the circle, and we draw the perpendicular bisector. This chord splits into two equal parts, and the bisector actually passes through the center of the circle, making this length the diameter. The next kind is when there's a tangent and also a radius at that point. So the tangent is actually perpendicular to the radius. So this angle here is 90 degrees. And if you have two tangents and two radius like this angle here and here are equal, and these two lines are also equal in length. And we call this tangents from external points. Now, this one is probably the most popular circle theorem. It's when you're given the diameter of the circle, and you see a triangle that touches the circumference of the circle over here. This angle here is actually a right angle, so it's called right-angled triangle in a semicircle. Okay, this one is quite difficult to understand, so let's go back to the idea of pizza crust. So if I create a pizza crust here, and draw any two lines from the ends of the pizza crust to the circumference, we get an angle over here. And then we just repeat it. So these two angles are actually the same because they share the same pizza crust. So we call it angles in the same segment. Okay, so let's try this pizza crust thing again. So putting these two lines to the circumference of the circle, but this time we put another two lines from the same pizza crust and it will go to the center. So the angle at the center is actually 2 times of the angle at the circumference. There's actually another weird variant of this where they still share the same pizza crust here, but it's like inverted. So the reflex angle at the center over here is still 2 times of the angle at the circumference. For the last circle property, we're gonna introduce this thing called a cyclic quadrilateral, where its 4 points are touching the circumference of the circle. The angles that are opposite to one another actually add up to 180 degrees. We call this angles in opposite segments because these two angles kind of share 2 different pizza crusts, which is this one and this one over here. I know that's quite a lot to remember, so I actually learned this secret technique to memorize circle properties which my good friend Dylan from Paradigm came up with. Dylan, are you there?
Since your favorite axolotl has summoned me, let me walk you through a mini phrase to help you to remember all the circle properties. Right, this is the simple phrase that you got to remember. Mr. Tan, 2 times 90 equals 180 degrees. Now, Mr. Tan represents tangent, right, to the circle is 90 degrees. Next, 2 times is angle at the center, is twice the angle at circumference. 90 refers to angle at a semicircle is 90 degrees. Now, the equal sign next refers to angle in the same segment are equal, and last but not the least, opposite angles in a circle adds up to 180 degrees. Okay, so hope it helps. Wish you all the best.
Now, for any long circle properties question like this, I usually look for 3 things at the start: radius, tangents, and diameter, which I call my RTD method. So, first, let's look for the radius. So these two are equal and form an isosceles triangle. Next, for the tangents, this tangent here is perpendicular to the radius, and these two tangents are from external points, so these two lengths are the same. And finally, since we have a diameter here, there's usually a right angle triangle in a semicircle, and here it is, and this is 90 degrees here. Now the question becomes 1,000 times easier for us to solve. To find the green angle for part A, since this becomes an isosceles triangle because of tangents from external points, the green angle is just 180 minus 58 divided by 2, which gives us 61 degrees. For part B, since this angle is 90 degrees, we can just do 90 minus 61, which gives us this angle to be 29 degrees. Now, since we want to find the orange angle over here, let's try to trace it downwards, and we can see that it has this pizza crust over here. So the orange angle is actually 29 degrees as well because of angles in the same segment. Now, to find the yellow angle, again looking at this pizza crust over here, The yellow angle at the center is 2 times the angle at the circumference. So we can just do 2 times 29, which gives us 58 degrees. And finally, for part D, since this angle here is 90 degrees, we can look at the triangle over here and we can just do 180 minus 90 minus 29 degrees, which gives us 61 degrees. I know there's other methods of solving this, like using the isosceles triangle over here, but you notice that by annotating the RTD circle properties at the start, it makes the question way easier. Wow, they really decided to cram all the heavyweight topics in Sec 3 for real. And I get it, there's like a ton of things to memorize, from the similarity and congruency tests to all the circle properties. The Sec 3 topics make up a huge percentage in the O-levels, and some questions seem to be really popular. Like for example, the long graph question seems to come out every year in paper 2, and there will definitely be a sine or cosine rule question somewhere in the exam. I can't believe it, we're down to our last main video in our Axolotl math video series. Trust me, the Sec 4 topics are a little bit easier than the Sec 3. So until then, all the best for math, and Axolotl out!